So one thing we can do with acid strength is predict direction of the equilibrium. And this sounds very familiar in terms of when we were talking about Le Chatelier's principle, we talked about equilibrium, which is when the forward and reverse reactions are going at an equal rate. And equilibriums can favor the left, right, which would be the reactants, or the right, which would be the products. So just to remind ourselves about that, when we're talking about equilibrium, there's two sides, right? So there's the reactant side and the product side. So this is considered the left, and this is the right. Now, we're not going to use Le Chatelier's principle, and we're not going to be shifting the reaction, but we're going to use acid strength to figure out if the reaction, if it favors the reactants, it simply means that when the reaction is going, there's more reactants than products. Or does it favor the products, which would mean when the reaction is going, there's more products than reactants. And so we're going to use the strength of the acids and bases in the equation to figure this out. Now, there's an underlying idea here. And here it is in more words, and then I'll show you. So this, it says, the stronger acid reacts with the stronger base to form the weaker conjugate acid and the weaker conjugate base. Okay, so that's a lot of words. But in a short, to summarize that, here's what we need to remember. The side with the weaker acid is always favored. So strong acids really want to react. Strong acids and bases, they really want to react. So the side that's strong will react to form the side that's weak. So we're going to get an equation. We're going to identify which side has the weaker acid, and that side is the one that's going to be favored. Okay, so I'm going to have some steps that I'll show you in words, and then we'll have a problem so we can apply this idea that the side with the weaker acid is always favored. Okay, so we're going to apply it. So here's the steps, and I'm going to work through these steps on the next slide. I have an example, but we're going to label our equation, identifying both the acid, which will be on the reactant side, so there'll be acids on the reactant side, and we'll identify the conjugate acid on the product side. So we're going to identify it first. Then we're going to figure out which one is stronger and weaker. And to do this, we're going to use table 9.2, which you do not have to memorize. It's going to be given to you. And then what we have to remember is the side that has the weaker acid is the side that is favored. The weaker side is always favored. All right, so that kind of breaks it in steps. Let's do an example. So it says, are the reactants or products favored at equilibrium? So the first thing you're going to do if you get this question is you're going to figure out who's the acid, who's the base, who's the conjugate acid, who's the conjugate base. So remember, don't follow the hydrogens. So I know these two are partners because they both have fluorine. And then I know that these two are partners because they both have oxygen. The hydrogens change. So then I compare. So this is HF and this is F minus. So to get from HF to F minus, what did it do? It donates or lost. That makes HF the acid and F minus the conjugate base. And I'm just abbreviating conjugate as CONJ. All right, so this is the acid. This is the conjugate base. Now I'll go through and label the other one. You might already be able to figure out what's what. But I see here, I see OH is here, and then it's H2O. So it went from having one H to having two. So this one accepts H+, which makes sense. That's what we would expect. One donates, one accepts, and that makes this the base. Oops, I don't know what happened to my pen. And this is the conjugate. Oops, not there. The conjugate acid. All right, so that's step one, is you label it. Now, we do not care about the bases in this case. To answer this question, we're going to compare the acids. So I'm going to compare this one and this one. Okay, I don't need to worry. I'll just draw a little line through this. These two I don't need to worry about to answer this question. So then what I do is I need to figure out which one of these two is stronger. And to do that, I'm going to use table 9.2. So I need to look up HF and H2O. Okay, so here is HF and here is H2O. So of those two, HF is stronger and H2O is weaker. So HF, this is the stronger acid. And this is the weaker acid of these two. I'm comparing acid to acid. Now, the answer, which I mentioned previously, is the weaker acid is always favored. So in this example, the weaker acid is on the product side, so the products are favored at equilibrium because they have the weaker acid. And remember, here in our reaction, here's the arrow, so the reactants are always on the left and the products are always on the right. And that's how you answer this question. So we use the strength of the acids to figure out if reactants or products are favored. And I know, and maybe you don't think this anymore after being in chemistry for a little while, but we always think if we put things together and they react, that they're always going to make lots of products. But that's not the case. Sometimes when we put things together, they barely react, if they react at all, which means then it would favor actually the reactants, that's what would be in the container. But in this case, we would get some products out because our weaker acid is on the product side and the weaker side is always favored.